Hey guys, we're going to do a video on geometric proofs. We're going to talk about congruent parts of congruent triangles that are congruent. I'm going to apologize ahead of time on this video because all of the triangles we're going to prove are going to come out the side angle side, and that's typically not how I run my videos, but that is the different examples that I have. So let's take a look at 3 examples. Alright guys, let's take a look at this first example. If you look at the given, you will notice that it's the same as any other given that we've covered in this series of geometric proof videos. But if you look at the proof, we're not trying to prove a triangle is congruent. What we're trying to prove is parts of these triangles are congruent. In my opinion, this is the reason why we prove triangles are congruent in the first place. Once we know that the triangles are congruent, we could start making a whole bunch of assertions about theorems and parts of triangles. So let's get started. So the first thing I want to handle is the parallel lines. The given tells me that AD and BC are parallel. So I'm going to place arrows to indicate which lines are parallel on my diagram. In parallel lines, they always exist alternate interior angles. So I am going to use those alternate interior angles as part of my proof. The way I select those alternate interior angles is I choose the angle that is associated with the sign with the arrow. In other words, I will not be using these angles. I cannot use those because in order to do so, I would need to have those sides to be parallel, and I don't have that. This angle is DAC, and this angle is BCA. So I'm going to write that up real quick in my table. And what I'm going to do now is mark off my congruent sides. So my given gave me AD is congruent to BC. So that means not only are these sides parallel, but they are also congruent. I need to make clear here, you cannot make assumptions. So, because AD and BC are parallel, that does not mean that they are also congruent by default. So you cannot make those assumptions. Those 2 separate statements need to be stated explicitly. Alright, let's finish up this proof. In the center here, I have a reflexive side. So I'm going to use that. And this would be AC and AC here. Now I think I have enough to prove my triangles are congruent. Let me take an inventory. In the previous proof video, I always say to take an inventory of what you have. So that is what I'm going to do. AD is a side, DAC is an angle, and AC is a side. Then BC is a side, BCA is an angle, AC is a side. I check my table. I have the side listed here, I have an angle, and I have a side. So that means I have enough to prove my triangles are congruent. I can state that triangle DAC is congruent to triangle BCA by side angle side. The one thing I want to pause here and point out is notice how on line 3 I wrote angle DAC. Then in line 5 I wrote triangle DAC. Those symbols are key to proving. You need to get comfortable with that. So AD with an over bar is suggesting a segment or a line. The Pac-Man sign for the angle is making it clear that DAC is an angle. Then the triangle sign in front of DAC is making clear or asserting that I am speaking of the entire triangle. Now comes to the part where we actually prove that DC is congruent to BA. So I'm not really too comfortable with this in the sense of how I mark this up. This is definitely a section you want to pay close attention to here. I need to prove that DC and BA are congruent. So what they want me to do is to be able to place these congruency marks here. Don't get confused. Those marks are appearing after we prove the triangles are congruent. I can make that statement now because the triangles are the same. So that means the individual parts of both triangles are also the same. The way this is typically communicated in many proofs is the term CPCTC, or congruent parts of congruent triangles are congruent. I avoid that acronym at all costs. And the reason for it is because what will often happen is students will get confused about what CPCTC means and then start writing it all over their proofs, even students that know how to prove. So I prefer to just communicate this in plain language. So I'm going to make a statement something like DC is congruent to BA because triangle DAC is congruent to triangle BCA. That's as close to plain English as we can get, and it definitely supports how we could say DC is congruent to BA. Alright, let's take a look at the next example. Okay, so in this example I saved you the joy of allowing you to watch me write out the given. And the first thing I notice is that KT bisects angle AKI. Angle AKI is here. Now, that angle is being cut in half by KT. So that means this angle and this angle are congruent. I have two ways I can write that angle. I could say angle IKT is congruent to angle AKT, or you don't have to write both. I can write angle 2 is congruent to angle 1. That is entirely up to you. And the reason for that is that KT bisects angle AKI. You can say angle bisector theorem. You can say some other stuff here for sure. But I just used a given to back up how I know my angles are congruent. As you get more advanced, absolutely use those statements. Now let's point out the reflexive side. If you noticed, or if you watched the other series of videos, you will have noticed that the reflexive property is a very commonly used property in proofs. That is not limited to, let's say, high school examples. I find myself, when I had to perform geometric proofs in college and other places, the reflexive property is an invaluable tool for getting these things done. So now, let me take an inventory of what I have. Okay, so I forgot to mark off KA and KI being congruent, so I snuck that in there. This is a side, this is an angle, and here's a side again. This is a side, this is an angle, and here's a side again. So, once again, these two triangles are congruent by side angle side. Alright, now comes the next part. To prove that the angle ATI is also bisected by TK. So what we have here is we have this angle being cut in half, or we want to prove that that angle is being cut in half. This is pretty tricky. The way you have to do this is you have to work backwards. So let's just take a second and review here. We knew that if KT is bisecting AKI, that means, or I could write it like this, that means that angle IKT is congruent to angle AKT. Well, we could do this the opposite way. I could just turn that arrow this way and say, I know that angle ITK are congruent to angle ATK because the triangles are congruent, proving that that big angle ATI is being cut in half. So let's write that up. And the way I wrote this one up was one of the classic ways to communicate CPCTC, which is congruent parts of congruent triangles are congruent. In my book, there is no difference between the way I wrote this in example 1 and example 2. You just have to find a way to communicate the fact that you know that these parts are the same because the triangles are the same. In the next video, next example, I mean to say, I will write that in plain English for you. So, let's finish this up. Now that I know that ITK is congruent to ATK, I could use that fact. So, I'm going to. So, there's a couple of ways to write this up too. One way is to do what I just did, which is to say take TK bisects angle ATI because angle ITK is congruent to angle ATK with TK in the middle. Or you'll see it in other proofs as the converse angle bisector. Again, definitely if you're a beginner prover, I would not stress the use of these theorems in technical terms. But if you're an advanced prover and you're watching this video for some reason, that's the way it's communicated. Just saying converse statement or the statement that an angle bisector theorem would make in reverse. Alright, let's take a look at the last example. Okay, so once again, I spared you the unending joy of watching me write out the given. Now, we're going to break down and prove that the triangles are congruent. In this case, I have two midpoints. And once again, you cannot assume what's being given. In other words, I cannot assume that if O is the midpoint of MQ, that it is also the midpoint of an opposite line, like PN. That needs to be stated explicitly. For the sake of your time, I am rushing through the midpoints. If you need to review the midpoint and bisector properties, you could check out a previous video that I made on just that. Now I'm going to use the vertical angles in the middle. Remember, whenever angles make an X, like they do in this diagram here with this bow tie triangle, they form congruent angles that are referred to, or actually technically named, vertical angles. I don't know why they're called vertical angles, because they're typically, or don't have to be, up and down, but that's what we call them. They're just angles that are across from each other that are congruent. Now I could prove my triangles are congruent let me just take an inventory. So once again, I have side angle side here, proving or allowing me to prove these triangles congruent using that postulate of side angles. So now I have to prove that line MN is parallel to PQ. I am going to place arrows on those lines to figure out which of my angles in these triangles are alternate interior. Please be careful when you do this. This is a place where you can really tangle yourself up. You do not want to place these arrows here prior to proving the triangles are congruent. Now, I can use angles that are associated with those lines with the arrows. And I could use either angle P and angle N because they're associated with the lines with the arrows, or angle M and angle Q. I'm going to use angle M and angle Q for no other reason that's what I chose to do. So these angles here are alternate interior. I can now make the claim that they are congruent because I proved my triangles are congruent. I could not have done this prior, so let me write that up. I made the statement that angle M is congruent to angle Q. And what backs that up is congruent parts of congruent triangles are congruent. I wrote that in plain English, which is just fine. Took me a couple of tries to smash all of that into that line, but I got it to fit. Now I can make my final statement that MN is parallel to PQ, and there is once again a number of ways for me to do this. I could just make the statement that angle M is congruent to angle Q and they are alternate interior angles. Or what I can do is I could just make the statement converse alternate interior angle theorem. My suggestion in these very, very challenging proofs is that you communicate your reasoning in terms you understand. Then, as you get better at proving at this level, you can use more advanced terminology or the theorem specifically. Alright guys, I hope you guys found this video helpful.